Okay, in this video we're going to have a look at the alcohols as a group of compounds, okay? And it's worth remembering that alcohols are an example of what we call an homologous series. So we've already looked at alkanes and alkenes, and they're also two families that are called homologous series. The way to remember what this means, homo means the same, and the logos bit means logic. So they are a family of molecules that have some similar logic, some similar patterns in their information. And they can be categorized as four key features. First one is they all have the same general formula. And then each family member only differs by a CH2 group. There's a gradual variation in their physical properties. For example, boiling point, as a molecule gets bigger, boiling point could increase. And they have similar chemical properties. So let's have a look how this works for alcohols. The first thing we need to do is write down the general formula. So general formula for an alcohol is CN, H2N plus 1, and then OH is what makes these alcohols. This is the functional group, so we can fill that in. OH is the functional group, and this is the way that alcohols react, and every alcohol will have one of these in their structure. Okay, just a reminder that N is any number. So any number you want, and then you work this out to get the number of hydrogens. Okay, so the names for these, the first one is methan, and then ol to indicate that it is a alcohol. And methanol has one carbon. Let's draw it first. So there's my one carbon. Carbon needs to have 4 bonds. We've already said that it has to have this OH structure, so that's what that looks like. And then these other bonds that are remaining, we add our hydrogens to that. So the formula for this is CH3OH, and that's methanol. Ethanol has got 2 carbons, so ethan, and then ol again to indicate it belongs to the alcohol group. Let's draw it first, so 1, 2. Let's put our 4 bonds, and then we put our functional group for an alcohol there. And here I'm going to fill the rest up with my hydrogens. So I can write that as CH3, CH2, OH. Okay. Next one, propane 1-ol and butane 1-ol. These are a little bit different, as you can see, because they've got this number in the name. This number is to help us to know where to put the ol group, the alcohol group, the group that makes this belong to the alcohol family. And what I mean by this is that there are 3 carbons because it's prop, and then I'm going to number these. So let's number these. I'm going to go number 1, number 2, and number 3. Okay, and what this means is that on carbon number 1 is my OH group, and then you put your H's on, making sure that you've got 4 bonds on every single carbon. Okay, formula CH3, CH2, and then I've got CH2 with the OH attached to that. Okay, and the final one, again it's one with numbering, butane 1-ol. So do the same. So but means there's going to be 4 carbons. Number them, 1, 2, 3, 4. On number 1 is my ol group, my functional group, the OH. Put your other bonds on to make it 4 for each carbon. Then put your H's on, and there is your structure. CH3, CH2 and a CH2, so CH2, CH2. Then you've got another CH2 and your OH, CH2 and your OH, okay? There's your structures. This is how you work the names out, so butane 1-ol and propane 1-ol, and that you number them up to get the 1 in position. Have a look at them, have a go at them. Good luck.